Hello and welcome to the Chapter 7 video for Statistics 2. This is meant to be a short review video of the content of Chapter 7, going over some problems and some content to try to give you an idea of what you maybe missed or forgot from Stats 1. So the first thing I want to talk about is the standard normal model. So in particular, the standard normal model is the model or distribution based of z-scores. So hopefully you remember, distribution. Whoa. Of z-scores. Sorry, it thinks I should be typing this. Anyway, so when you think about the distribution of z-scores, it's all of your standard scores. Just a reminder, z-scores are what you are trying to find when you're looking at a value in particular you're interested in. This is just the formula for it. Subtract the mean, divide by standard deviation. So if you're trying to do a z-score of some particular value, you're trying to decide, is that value unusual or not? Or how far, so if you're looking over here, how far is it from the mean? Subtract from the mean. And when you say how far, like, you got to be careful because your mean might be 0, in which case is 100 far away, or is 2 far away, is 3 far away. If you're looking at a quiz, is it 2 points? Is it 100? Is it 10? I mean, it depends on what your scale is. Is this percentages? Or, I mean, how do you do distance? Well, you decide if something's unusual or far away if you know the distance. So our distance that we use here is the standard deviation. The standard deviation is your average distance from the mean. It's a distance. So when you look at this, what the z-score is really up to is it's taking how far am I from the mean measured in standard deviations. That's why it divides by it. So it's telling you how many standard deviations am I from the mean. Am I unusual? Am I really far away from the mean? And it has two possibilities. It could be positive or it could be negative. So am I really below the mean or really above the mean? So when you start looking at z-scores, you can actually form a distribution. Now, if we're forming a distribution for this guy and it's normal, that means it's going to have a particular shape to it. So it's going to be bell-shaped. Ooh, this is supposed to be symmetric. And it's unimodal, so one peak. So as you look at this, the very center of this is going to be your mean. Well, if my center or my value of interest is the mean, well, when you take something and subtract from itself, you get 0. So the center of this is going to be 0. And then if I'm one standard deviation above the mean, well then how far am I above the mean? One standard deviation. That's just going to be 1. So I could be 1 above. I could be 1 below. This will be negative. Woohoo. It could be 2 above. Be 3 above. Hopefully the inking is helping. We don't know. When this happens, we say that z is normally distributed with mean 0 and standard deviation 1. So there's certain conditions in which you get a normal distribution, and we'll talk a little bit more about that as we go further in the notes for this. And then the last thing you want to note about it is area, in this case, is equivalent to probability. So this is something you learn from doing other distributions, like the stuff from Chapter 6. Area is probability. Woohoo. Alrighty, let's move on. The first thing we're going to do is we're going to look up some normal scores. So I'm going to find the percentage of values that are in the particular region. So I'm going to draw little mini bell curves for this. And hopefully they won't look too terrible. So remember the center is 0. Alright, so I want to be less than 2.91. So that's 0. So 2.91 is probably somewhere over here. I'm guesstimating, so we'll call that 2.91. No. 19. And in particular, I want all the stuff less than this. So I'm looking at this as all the z-scores that are lower than 2.19, which is this area. So I want the stuff to the left of 2.19. How do you do that? Well, you go over to the table. So the table I have here is the standard normal table. You'll also find this along with this notepad and with the video. And in particular, you'll notice it says, hey, these are area to the left of the z-score listed. So along the left-hand side, you see the z-scores themselves, along with your secondary decimal places along the top. And then in the middle of this table will be the area. This is not the only way to calculate this. It's actually my least favorite way to do so. I actually like to use Minitab to do this way better. All right, let's take a look. Where is the positive ones? Because I need 2.1. So here's 2.1, so I know it's in this row. and then I need 9 as my last decimal place. So 2.1 and then 9. So it starts at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's the last column. So 2.1, go to the last one, 9. So here's my value that this area would be. So, oops, draw with touch. This area is 0.9851. Is that a 1? That's a 7. Ooh, I can read 4. So the probability that I get a z-score that is less than 2.19 is 0.98574. That's a lot. So most things are, like pretty much everything, remember total area is 1, is below 2.19. Let's look at the things above -3. So -3 is probably somewhere out here. We'll call that -3. And I want to do all the values that are bigger than -3. So all the stuff to the right of -3. And that's going to be a little bit of the problem. So if you look over at the table, remember this does area to the left, not right. Oh no. So in particular, go to 3. This is the stuff to the left. So if we're looking at our picture, that's the stuff over here. But in total, I need to end up with 1. So I can actually do subtraction to get what this is. So 1 minus, what's 3.01? 0, 0, 1, 3, 5. Ooh, that's written terribly. So hopefully you get the idea that if I'm going to do a right every single time, I'm going to be doing a subtraction. So I'm going to have to subtract it from 1. Now, this is only if you're going to use the table. If you're going to use other means to calculate this, you will not have to do the subtraction bit. Unless you are using the calculator. The calculator likes to do lefts only too, depending on... Well, actually, that's not even true. I'm lying a little bit. Depending on how you want to enter it in, it does lefts better than rights. Anyway, so let's do an in-between value. So I want to do the values between 0 and 1.3, which I'm putting randomly right there. Ooh, the sky one. Let's color in with pretty sparklies. Ooh, I'm sort of loving this. That's kind of pretty. I'm never doing that again. That's too distracting. Okay, so if I look up 1.3 in the table and scroll down to 1.3, that gives me the area to the left of 1.3, which is a little bit bigger than 0.9. Yeah, but that gives me everything. Like everything to the right. Or sorry, everything to the left. But I don't want this stuff. That stuff's not a part of what I want. I only want the stuff up to 0. So the easiest way to do this is to subtract off the things you don't need. So what you could do is you could look up 0 in the table, which you find right over here to be a half. Yeah, because it's half the distribution below 0. Huh? 50%? 0.5? Okay, that's how you're going to do this. So I'm going to take the probability from 1.3, the 0.90, where was it? I just lost sight of it. Why am I having a hard time spotting this on the table? Because this is really small on my screen. 320, and I'm subtract 0.5 from it. So I'm going to get 0.40320. So how do you do in-betweens or in between two values? You subtract their table values. So you take the lower probability and subtract it from the higher probability. Cool. I regret writing this question already because I'm betting you guys don't remember absolute value. Maybe. No? Guess we'll find out. What is happening? Okay, so here we're going to have to be careful what we are calculating because it's absolute value. Remember, absolute value is just like what is its distance from 0. And here you're looking at, oh, whatever value I am considering, its distance from 0 is less than 1.67. So you could start this out by drawing like the positive half of it. Like, oh, there's where 0 is roughly. Here's 1.67. Da 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 da. Ooh, that came in great. So that includes everything in here because all the stuff in between here is less than 1.67 in distance from 0. But you also get all the negative stuff because absolute value makes everything positive is another way to think about it. So 1.67, and it's only because this is a less than that this happens. If it was a greater than, it would actually go the other way. So I want the area between these two. So you could look them both up. That's one way to do this. There are many ways to do this one. 1.60, 1, 2, 3, 4, 5, 6, and then 7. So this one. 0.98574. 0.5254. I'm going to need a calculator for this one for sure. The other ones I was doing in my head. All right, now I got to look up the negative one. Negative 1.60123456 Notice when I'm counting this, I also count the zero position because that first column is the zero position. 04746. Okay. Oh, I don't really have a calculator handy. Oh no, hold on a second. I'm so glad that this is going to show up on the recording. Fast, 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 fast. Just kidding. 0.95254 minus 0.04746. Ta-da! So in total, and this will be 0.90508. Interesting, right? Oh yeah. Now let's take this and flip it and reverse it. So we've been doing given a z-score, find an area or probability. Now we're going to do given an area, find the z-score. All right. So here we're looking for what score of values corresponds to, oh, no, go back to the drop menu, corresponds to the lowest 40%. So I want this stuff to be 0.4. All right. Again, there are other ways to do this besides the table. So I want my area to be 0.4 and it's to the left, so that means I can just look it up on the table. So where is about 0.4? So there's 0.5. So usually what I do is I look down this first column and look for something close. So notice this is 0.38, that's too small. 0.42, that's too big. It's got to be in one of these two rows. Who is closest? That one's pretty close. Oh, one of these two. Okay, who's closer? This is 0.1-ish too big, and this is 0.3-ish too small, so it's actually this one. So what value does that correspond to? Negative 2, sorry, negative 0.2, 0, 1, 2, 3, 4, 5. So this value is going to be z is negative 0.2. Oh no, I lost track of what it was already. Was that 5? 0, 1, 2, 3, 4, 5. Yes, it is 5. Cool. All right. I'm drawing this a little bit bigger so it's easier. So I want the upper 2.5%. So be careful here. Remember, 2.5% is actually, you should be thinking of this in the decimal form. I don't know why people do this, but for some reason people don't use the decimal equivalent instead of the proportion. Why is it doing that? Anyway, so I want my area, nope, to be this little bit. I think it's because when I push down, sometimes it activates the keyboard. Okay, and that's a problem because that's a right, and I can't do right. So instead what we're going to do is we're going to figure out what the left area would be that goes with that. Usually I do red for right, and I forgot to. 0.025. So this part would be 0.975. So that's what I'm going to look up instead because the table only does lefts. And find the z-score that does that. So this is going to be pretty big, so it's got to be on the positive spectrum since I'm doing area to the left of the positive. See, 9.7. Ooh, it's got to be one of these two. Oh, that's pretty close. Oh, that's pretty close. Boy, these are really close. Okay, so again, I'm just picking the one that's closest, which it looks to be this one right here. So my z looks to be 1.7, and then it's right next to the 9 column, so this is going to be 8, because it's just one less than that. Perfect. All right, now let's do the middle 75%. So here's where we got to be careful. And I'm going to do this very sneakily. So I want the area in the middle. Rainbows, that's so distracting. I want this to be 0.75, which means the tails together make 25%, or 0.25. So take that and divide it in half, and that's exactly what you would get for just one tail. Now, I can divide this in half because it's symmetric. So this is going to be 0.125. Perfection. So I got to find that on here. It's going to be -2. And I'm choosing to do the lower tail because area to the left. This is area to the left of whatever z-score this happens to be. Neener, 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 neener. Let's see. 0.12, ooh, somewhere in here. 0.12. I'm looking for a 5. Look at. Ooh, this one's like dead on almost, right? It looks like it's negative 1.1. I need to figure out how to turn that off because that is super obnoxious. So let's see. 0, 1, 2, 3, 4, 5. Okay, now the fun part. Since the normal distribution is symmetric and we're looking at a symmetric central area, I can just use the principle of reflection, since this is symmetric, to figure out what the positive one would be. So this would be 1.15. So between negative 1.15 and 1.15. Or if you don't like that, you can use the inequalities to write this. Beautiful. All right, this is already 15 minutes long, so I'm going to stop the recording here. Done for now.